Hi. Oh, hasn't it get recorded? Okay, it's recording. Uh, did everybody get your tute and kind of like the Vernier instrument? Hello? Did you receive your Vernier instrument and tute together? Only like few students just let me know about then their tute and stuff. They sent me photos of the tute and the instrument, but others didn't send tell me anything about. Okay. Okay. Mhm. I'm pretty sure because it's registered post. Normally, registered post pay like 10,000, one in a 10,000 type of that thing. So I'm pretty sure everybody may have received the tune and the Vernier instrument. So uh, you know what? For this time, I calculated the amount of money I spent in stationery item for this month, including your budget was the very high because it was like nearly 1,200, 2,300 for one student I spent on stationery. So normally this month I have spent almost like 188,000, including other badges as well. So why did I spend such a big amount on you? I could have just boosted forth in that money and I can get more students. But my need is I need to get really quality students, quality. I always targeting the quality output. So here the Vernier principle is not something really catchy at instant. Because why? So there are certain things you have learned in your life, somewhat extent. But you can go for the next step because you have learned. But unfortunately, the error concept you learned for the first time. And the Vernier concept is really essential to understand micrometer concept, spirometer concept, as well as traveling microscope all together, right? So that is why my plan was giving you to study about Vernier concept, right? Because Vernier caliper, firstly, you should know what is a Vernier caliper, how does it work, okay? Because this concept is something new, something really new. So today I am going to just remind you about error concept a bit, just a bit, error concept, then go forward. I told you I am going to complete the error lesson while doing the questions. Because if I straight away go for the in depth of error concept straight up and continuously, it is going to be like a headache for you. So I am going to remind you something. So whenever there is a certain reading, there is a certain scale. You do what? I am just targeting the third line. I'm just targeting the third line. Now have a good look at when you keep something, it looks exactly on third line because the scale is very big. The scale is very big. But imagine if the scale was something like this, very close by. You are targeting this line, X. Now I am going to keep it in front of X. It looks as if it is in line with X. But the actual thing is, it might be somewhere to the right or somewhere to the left. Right? It might not be exactly on top of the third line. Can you understand that? Can you just understand that? Hello?
Yes, sir.
Yeah. Okay. Now the problem is, if I just move to left by the unit, the maximum tolerance is the previous one, x minus 1. I will go for a numerical value. If this is the third line, that means the second line. and next line is fourth line. Half of the previous line, that means it can be between 2.5 to 3.5. So this is called the uncertainty. 0.5 from the previous line to the 0.5 to the next line. Altogether, one line. Okay. Altogether, it is a one line, one whole line. Can you understand this? This is called the uncertainty. Uncertainty means you are not sure your answer is 100% correct. So imagine like you got a value. Imagine you get like 1 for this, 1 any unit. Okay. So if your reading is 18 such units, so your uncertainty is 1. It can be added up 1 or subtracted 1. So plus or minus 1. This is how you write the answer with your uncertainty. Normally, uncertainty is the least count. Can you understand? So that is why I told you in the last week, sometimes this is exactly equals to the absolute error. Sometimes. That means the acquired reading and the expected value. Normally, sometimes the absolute error is nearly close to the uh, least count. So these are like the two sides of a same coin. So it can be like the least count might be equals to uncertainty. Okay, right. Okay, forget about it. So normally, for with really good skill of reading, we can avoid and minimize the amount of error. So normally we have to go for the percentage error. Percentage error. In terms of the percentage error, it is about least count divided by reading multiplied by 100%. This is all about it. I reminded you this in the other video as well. I just made 2 videos now. So you have to remember one thing. The maximum tolerance of physics is just 1%. So the percentage error, you can't exceed 1%. So for meter ruler, you had something, the least count of 1 millimeter divided by the minimum reading multiplied by 100. So come to think of here. When you get the minimum reading subjected, so it is going to be 1 millimeter multiplied by 100. It is going to be 100 millimeters, right? 100 millimeters. Perfect. 100 millimeters. So you can't measure anything smaller than 10 centimeter. That means 100 millimeter is equals to 10 centimeter. You can never measure anything smaller than 10 centimeter for any advanced physics application. If you are just measuring something like a length of a pencil or something, you can use it, no problem. But whenever you are applying it for higher advanced physics applications, you can't. I told you something about that shooting the American president thingy. It exactly happened in the last week. No, see, I'm like a Simpson. So Simpson cartoon series you might have seen. In the Simpson cartoon series, they like predict things happening in the future. No? So here, my prediction went absolutely right in this time. No? If you have watched the news about Donald Trump's shooting incident, it is not always about the shooting thingy. Sometimes there is a thing called, have you ever heard boring engine? Boring කියන්නේ කම්මැලි engine එක නෙමෙයි. We are talking about something called reboring an engine. Have you ever heard? Reboring an engine. Have you heard that? No. Reboring means there is a thing called sleeve and the piston. It is like an injection syringe type of thing that goes in and out of that sleeve. So if the sleeve and the piston has a gap, engine begins to knock. That means it is not smoothly running. Fuel wastage is really high. Engine begins to vibrate, and sometimes engine stops. So you have to now make a new sleeve and piston system and exactly fitting into each other. So you have to go for something called lathe machine operating institute. Have you heard something called lathe machine? You might not know. You may have seen that boards are there, lathe machine, lathe operators and stuff. So those lathe workers do what? They scrape the certain sleeve until to fix to the piston. So they use really high accurate vernier instrument to do that. Okay. I'm planning to make some videos regarding going to those places and asking them to show you the real working mechanism with the vernier. So those people use it practically. So the vernier instrument application, that's why I told you, those boss people know much better. So if they know, why can't you understand? But they don't know most of them don't know the physics behind this, but they know how to take the readings. But in many classes, they teach like the way how they teach the mechanic people. Just show the parts and telling them to take the reading. This year, 2024, if you see that Sahira College, Maradana Sahira College, first term test paper, there were 3 or 2, I can't exactly remember, MCQ questions based on vernier scale. If you don't know the basic, you can never do it. If you are just trained to do, you can never do it. So I am training you to get the deep concepts, because I can also teach in that way, sugar coated. So sugar coating, why? Just teaching the basics and go forward rushing. So some of your friends may have done completely all the instruments. They have no concepts, because with concept cannot be done like that. Okay. If you also requesting me to do in the sugar coating method, I can do it. Now tell me whether do I need to teach you sugar coating method or extract deeper concepts. Tell me. Because in the final exam, your deeper concept knowledge will be tested. But in this class, I can make it like a very user-friendly environment, without teaching deeper concepts. What do you like? Quickly tell me. What do you like? No sugar coating. I can easily do sugar coating and everybody would like and embrace the class. Wow. But actually, you think like you thought, understood. Finally, in the real exam, if you are getting something thinkable question, you cannot. Okay. Now have a good look at here. This is the minimum reading. So I told you, if you want to get certain reading smaller than, so 1% means it is a fixed value. Can't reduce. 100 is a fixed value. If you want to take something smaller than 10 millimeter, sorry, 10 centimeter, what should you do? You have to reduce the main scale release count. Okay. If you divide the 1 millimeter into small parts, it is undoable. Why? Because 1 millimeter is not this big. 1 millimeter is a very small distance. So, in a single scale, you can't have anything smaller than that. Anything smaller than that. So you have to go for double scale then. Double scale then. Okay. Just give me a 1 minute. for me to get the sellotape pen. I made a very big scale than the last week. This rigiform is exactly 1 meter. Exactly. I will show you how to work it. Okay, I found it. Wait. Enough, no? Right. So I calibrated this with exactly 10 centimeter for each, right? I calibrated this with 10 centimeter for each. I'm requesting you to do one thing. You have to forget about it as a 10 centimeter. You have to think this 10 centimeter equals to 1 millimeter, representing what? This each 10 centimeters gap representing what? Tell me. I need to see whether understood. What is this 10 centimeter represent?
1 millimeter.
1 millimeter. Very good. Now, this is the main scale. Main scale. And this one is representing the vernier scale. Vernier scale. This gap is like, now represent 1 millimeter. Wrong. I think I'm writing with the wrong marker. Okay. One millimeter. Here the gap is 9 millimeter. Sorry, 0.9. 0.9 millimeter. Okay. In the vernier scale, you are actually making the scale with 9 such divisions. I am going to choose this 9th line. 9. 9 such divisions of the main scale into 10 such divisions. Okay, see? 9 divisions. I divided that into 1, 2, 3, 4, 5, 6, 7, 8, and 9. 9 and 10. I divide that into 10 divisions. So what is the least count of vernier scale? Let's see. Least count of vernier scale. That means vernier scale division. What is the total length I choose? What is the total length I chose? 1 millimeter. 1 millimeter parts into how many parts? 9 parts. So 1 millimeter into 9. Okay. 1 millimeter scale into 9 parts. I divided that length into how many parts? 10 equal parts. So what is my least count is going to be? What is my least count is going to be in the vernier scale division? It is going to be 0.9 millimeter. Can you understand that? Can you just understand that?
Yes, sir.
Okay, great. Now, have a really good look at now. When I keep this together, zero line of the main scale in a line with zero line of the vernier scale. You can clearly see there is a gap between the first line and the main scale and between the first line of the vernier scale. How much should it be?
0.1.
There was a ruler. I can't find it. Where did I keep it? Give me 1 second. Can't find it. But somehow you can understand it is exactly in terms of centimeters. In terms of centimeter, this is a 9 centimeter. This is 10 centimeter. Difference is 1 centimeter. Right? Difference of 1 centimeter. I told you to forget about 1 centimeter. So the gap is what? 0.1 millimeter. Can you understand? Can you just understand? Correct. Okay, perfect. Right. Now I want to find out the least count of the instrument. It is going to be main scale division here minus vernier scale division. So my least count is going to be 1 millimeter minus 0.9 millimeter. So my reading is going to be the least count of this instrument 0.1 millimeter. Can you understand? Can you understand? Okay. Did I give you a note about least count of vernier scale in the last week? What is the last note you have written? Yeah. Can you just tell me what is the last note you have written? Because I couldn't watch that video and come back today. I hadn't had time today. Can you tell me what is the last topic, last part you have written in your note? The least count of the vernier scale only, not the vernier caliper. Vernier caliper formula about this. Okay. Now complete this one. Least count of the vernier caliper is main scale division subtracted by vernier scale division. It is going to be 0.1 millimeter. Sometimes you may need to know it in centimeters. It is 0.01 centimeter because you have to divide it by another thing. Okay. Copy this, and I have to explain. Right. Okay. The vernier caliper readings are taken in following way. That is the last line, and I told you it is almost 11:43. Let's wind up the class, no? I remember. Okay. Shall I erase this? Yeah. Shall I erase this? Okay. Now write this in a new line. If you haven't written the topic, write it like the vernier scale reading. Sorry, vernier caliper reading is for vernier caliper reading is taken in the following way. Vernier caliper readings are taken in the following way. Firstly, tell me what is the way. Have a good look at. Don't write anything. If I keep my finger here, What can be the main scale reading? Main scale reading. Here. It starts from here, 3 millimeter, right? Okay, now write. Vernier caliper consists of a main scale and a vernier scale. Vernier caliper consists of a vernier main scale and a vernier scale together. Readings are a combination of, okay, vernier calipers. Vernier caliper readings are consist with two readings. Number one, main scale reading and vernier scale reading. Or you can write it like it comes in combination of main scale reading and vernier scale reading. Whatever the way you have to write. Firstly, let's learn how to take main scale reading. Okay, now write this in a question form. How to take main scale reading? How to take main scale reading? Okay, look at this one again. Remember, imagine like my tip of this pen act as if an indicator. I slide along and I stop here. What is the reading of the main scale now? What is the reading of the main scale now? Hmm? Yes, that is 7, 5, 6, 7. Right. Okay. If I hold it to here, if I hold it to here, 5, right, 4 millimeter. It is 4 millimeter. But there is a problem. There is a problem. Right? If I draw a line like this, dot line, now there is a gap between here and here. X. Gap of X. Now, do you have any idea about that? You can't guess and write. You can't say it like 4.5. You can't say it like 4.3. You can't say it like 4.6 because it is not calibrated. Can you understand? This 1 millimeter is not calibrated. Furthermore, you can't say decimals of millimeters. Understand? You can't say decimals of millimeters. Now only the vernier scale come to act. Okay, have a really good look at. I am going to bring this little bit closer. This one little bit closer. This camera setup a little bit closer. Now look at the gaps. It is like a one. Think in centimeters. Now think in centimeters. 1 centimeter, 2 centimeter, 3 centimeter. Gap is getting wider. 4 centimeter, 5 centimeter. Again 6 centimeter, 7 centimeter, 8 centimeter, 9 centimeter. In terms of millimeters, 0.1 millimeter. 0.1 millimeter times 2. That means 0.2 millimeters. 0.1 millimeter times 3. That means 0.3 millimeter. 0.1 millimeter times 4. That means 0.4 millimeter. Come to the last one. 0.1 millimeter times 9. That means 0.9 millimeter. Okay. Now, if I just move this forward, now see the first line and the first line of the main scale and the first line of the vernier scale coincided with each other. Can you see? What can you understand now? That means the vernier scale has moved to right by what? One part of the least count, that of 0.1. That means 0.1 millimeter. Can you understand it? Or if you don't understand, I will repeat it for second time, third time, fourth time. It doesn't matter. Can you understand it? Is there anybody who didn't understand? Okay, one more time. No problem. Have a good look at. Now there is a gap of 0.1 millimeter. If I move this forward, now the first line of the vernier scale is exactly aligned with first line of the main scale. How long did I have to move? Only a one part of what? Least count. One part of the least count got moved forward. Understand? Okay. Now have a good look at. Now I am going to align this line. Okay. See, 0.1, 0.2, 0.3, 0.4. How many parts do I have to move? 1, 2, 3, and 4 parts. See, I will move one by one. 1, 2, 3, and 4. When it move exactly 4 small divisions, it will come align with the fourth line. Can you understand it? Okay. Now have a good look at. That's enough. So if it is sixth line, how do you write? How do you write the vernier scale reading? If you have to move sixth line until the sixth line, how do you write the vernier scale reading? Very good, Pabasara. Very good. But you wrote in the wrong way. Final answer is correct. No. I'm asking how do you write? I ask you how do you write? Now have a good look at. You have to move 6. Very good, Pavani. Very good. 6. You have to move it until the 6th line. Have a good look at. Mark 6 line is this one. If I move forward until it to meet anything, see, 6th line to 6th line, align, it had to move how many parts? 6 parts. Let me mark it like this. Sorry, here. 1, 2, 3, 4, 5, 6. I just divided it again. Have a good look at. Now align with the 6th line. 1, 2, 3, 4, 5, and finally 6. Okay. 6 lines, it has to move forward of the least count of 0.1 millimeter. So what is the minimum reading of, vernier scale reading? It is going to be 0.6 millimeter. Can you understand it now? Okay. Now I will go for the sugar coating method as well. Now, finally, firstly, I explain in the concept. Then I go for the sugar coating. Now I am going to go for the sugar coating. Now you don't need to think of anything. When you are taking the reading, you have to read the main scale reading. you have to add Vernier scale reading. This is the sugarcoat method. Vernier scale reading. Now see, main scale reading is directly the main scale reading. Vernier scale reading is n multiplied by least count. N times least count. What is the n? N means the coincided line. Least count means 0.1. This is very much of easy. That is sugar coated. Now, if it is the 8th line getting balanced, okay. Now see 8th line in balance. See, this is not balanced. This is not balanced. This is not. 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 But the 8th line is. So, what is the? Please, how to find out the Vernier scale reading? 8 times 0.1. That means 0.8 millimeter. This is called the sugar coating method. Sugar coating method is very easy to understand, but you don't have any concept in your head. In the final exam, it might backfire you. Now I explain both in both ways. First in the real conceptual way, then in the sugar coated way. You know now everything. Okay. Right. Don't write anything. Now start to write how to. I told you like how to take the main scale reading. Write it. In a vernier caliper, there is no such indicator like moving forward like this with the index. Only index is the 0th line of the vernier scale. Now write the 0th line. Write it. The 0th line. The 0th line. The 0th line of the vernier scale. Of the vernier scale. Act as if. Act as if. Act as if. Indicator for the main scale. Act as if the indicator for main scale. Indicator for the main scale. Okay. Now have a good look at it. If I just place it here, somewhere here, what is the main scale reading now? I told you 0th line is the indicator. What is the reading of the main scale? Tell me. Yes. Babasara correct. Others? Senuri correct. Others? Isara correct. Others? Yeah. No. Not 0.5. Not 0.5, my dear. Main scale reading. It is the 5. Main scale reading is in millimeters, not 0.1. It is directly 5th line of the main scale. Okay. Let's write an example. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It goes forward. Now this is my vernier scale. Main scale. And this is the vernier scale. What is the reading? What is the reading? Now have a really good look at here. The reading is over here now. The reading is over here. Because the 0th line of the vernier scale act as if the indicator. What is the main scale reading? Main scale reading is 5 millimeter directly. Can you understand? If not, let me know. Okay. Can you understand it? Okay, copy this. Copy this into your answer book, your writing book. Copy this in your writing book. Okay. Copy. Did you copy? Did you copy this? Okay. Now write. Now there is a gap between fifth line of the main scale, and the Vernier scale zeroth line of the Vernier scale. See, there is a gap. There is a gap indicated by this right arrow. This reading can be taken by Vernier scale. See, now you have to find this. It is the n times least count. N times least count. Copy this part into your book now. Copy this part into your book. Copy this part into your book. Now write this in a new line. It is gonna be calculated by the line. Highlight this part. The line of Vernier scale. The line of Vernier scale in line with any line in the main scale. Okay. Now I told you this is in the somewhere here after 50. Now I will keep it over here. Now see with what line is that coincided with? With what line that is coincided with? See, in the main scale, we are not talking about the main scale. You only check the Vernier scale. First line is not, second line is not, third line is not, but the fourth line is yes. Fourth line is yes. No, 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 no. Wrong, wrong, wrong. Have a good look at again. Fourth line is yes. Which line is coincided? I asked only which line is coincided. Coincide means two lines align. First line is not, second line is not, third line is not, fourth line is yes. No, it is the fourth line, not the fifth line. Okay. Now let me draw that incident. I will draw something relevant to this diagram. I will draw something relevant to this diagram. Have a good look at. This is the fifth line. 6, 7, 8, 9, 10. Now have a good look at. You kept your Vernier scale here. First line is not. Second line is yes. Third line is again not. Fourth line is again not. Now which line is in contact? According to this diagram. Huh? According to this diagram, which line? Second line of Vernier scale. Can you understand? That is the second line of the Vernier scale in contact. Can you understand it or not? Can you understand? Yes. Okay. Now how to write the reading? Reading is equals to main scale reading plus Vernier scale reading. I have to go to there. Main scale reading is 5 millimeter plus Vernier scale reading is what? 2 lines multiplied by 0.1 millimeter. So your answer will be 5 millimeter plus 0.2 millimeter. Finally, 5.2 millimeters. Understand? Can you understand? Can you understand? Okay. Now yes, no? Okay. I want to ask you a question. Copy this one firstly. Now this is enough. I will remove this. Okay. Right. I hope you copied. Copied? Ramai? I would like to ask you one thing. For this type of things, for this type of questions in the 3D space, I can show you the variation in really nicely in a graphical interface. So shall we move on to my share screen for a while? The thing I show you in the second day. So in that one, I'm pretty sure you can learn well. But if you feel really uncomfortable, let me know after 10 minutes. Right? I will just give you a time of 10 minutes. After that 10 minutes, give me your what. Then if you don't like it, I will just come back to this board and explain you. Because this board is really like, tighten my both hands, because the variations are very limited. So for some parts, I have to use like external gadgets and explain. So shall we move? And after like 10 minutes, let me know whether it is suitable or not. If there are like at least 2 or 3 students, they don't like that, I will come back to the board. Okay? Are you ready? Okay? Because I am going to send you a midweek, on the spot worksheet. In that on the spot worksheet, it is going to work really well in that one. Let's move to that board. Have a really good look at now. I can explain you really well in this. So now for this type of questions, it is kind of weird. Have a good look at. It will test your spatial recognition ability. Okay. Now you can see only the ninth line is visible. Ninth line is visible. Now the 0th line has gone past something. 9 mean it is in the centimeter scale. 9 mean it is in the centimeter scale. How can you find out the other line? So you will have to go back. The leftmost line is, so the leftmost next number is 8. So this is 8 point something. First line is 8.9. Okay, 8.9, 8.8, 8.7, and 8.6 are. The line just immediately gone past by the Vernier scale is 8.6. So the main scale reading is 8.6 centimeter. Do you like this? Can you understand this? Okay. Now let me enlarge it one more time. And you will be clearly able to see there is a slight gap. Very slight gap. I can feel this like this way. This gap you have to read. This gap you have to read. That can only be done by checking which line has exactly coincided. Check first line is not, third line is not, fourth line is not, fifth line is not, sixth line is not, seventh not, eighth not, ninth not, 10th not. Actually, the second line is in line with any other line. You don't want to check what line that is, but you only need to check is what is the line it got contact with the Vernier scale line. Sorry, any main scale line. That is the second one. I told you Vernier scale reading you can read in the way how Vernier scale reading can be taken in n multiplied by least count. So what is the VSR n is 2, what is the least count? 0.01 centimeter. Understand? Can you understand? And as I told you, the total reading is addition of reading is main scale reading, that is this one, plus Vernier scale reading. Okay. Now see 8.6 plus 0.02, the final result is 8.62 centimeters. Now don't you understand? For some explanations, some calculations, this board will help you more than regular whiteboard. If you understood that, let's calculate few readings. I don't need everything. So wait. Do the question number 5. Do the question number 6. Do the second one and the 9th one. Okay. Question number 2, 5, 6, and 9. Do this. I will give you only time of timer will also be shown here. I'll give you a time of it is too much. 6 minutes. That's more than enough. Okay. Try this yourself. I'm going to give you 6 minutes. After the end of 6 minutes, let me know the condition about the board. Then I will go back to the whiteboard, stay here and do few questions and go back to whiteboard again. I will definitely go back to whiteboard. But after 6 minutes, tell me your judgment about this. Now start the time. Now see, only thing is you have to pay really good attention when you are doing something for the first time in your life. Right? When you do something in the first time in your life, you have to pay a little bit more attention. That's it. Okay, firstly, I will explain you here and I will get your vote about this board later. Here. Now, you know one thing, the reading is nothing, main scale reading plus Vernier scale reading. Now you can see the main scale reading. It has just gone past the 0th line. So the main scale reading is 0 plus the Vernier scale reading. Let's see. 1, 2, 3, 4, 5, and 6 is just exactly in touch with that. So my reading is going to be 6 multiplied by 0.1. So the answer is 0.6 millimeter. I think it is obvious for everybody. Many students, I think almost everybody sent me the set of answers. Copy this. If you didn't do, I will give you only 10 seconds. Okay, that is done. This is also a counting back thing. Have a good look at 6th line in centimeter. Now that means you have to go back until to the 5th line, 5th centimeter. So 5.9, 5.8, 5.7, 5.6,
5.5, 5.4. This is 5 point what? This is the main scale reading. And there is a slight gap. Gap is the first line. First. So let's go for the reading. Reading directly equals to main scale reading that of the, okay, what is it? 4 point, yeah, 5.5, 5.4, 5.3, yeah, 5.3 centimeter plus, let me check, yeah, 5.9, 5.8, 5.7, 5.6, 5.5, 5.4, 5.3, yeah, plus 1 times 0.01 centimeter. That means my reading is going to be 5.31 centimeter. That is an obvious result, very easy to get. Now here, 3.9, 3.8. So get me go for the reading. 3.8 centimeter plus, what is the line got past? Third line, 3 times 0.01 centimeter. So the answer is 3.83 centimeter. Understood? Now the last one. 1, 2. So the reading on the main scale is 2 millimeter, or in centimeter scale 0.2 centimeter plus Vernier scale, something fourth line, 4 multiplied by 0.1 in millimeter. In terms of centimeter here, 4 divided by 0.01 millimeter. So the answer is 2.1 in millimeter. Here in the centimeter scale, 0.24 centimeter. Whatever the answer, accepted here. Understand? Can you understand? Hello? In the second case, I didn't take 0. What? I took 0.1. You are talking about here. I took millimeters. I took it as millimeters. If you want me to get the centimeter answer, I can write it like centimeter 0 and 6 times 0.01. So the in centimeters, the reading is going to be 0.06 centimeter. Understood? Okay. Right. Now I am going to get your vote about this board. How do you think this board? 4 question discussion. I'm not going to discuss all the questions, but sometimes of this type of tricky. How do you think? Is this suitable for you or not suitable? Quickly let me know. Everybody, I need your opinion. If you feel really uncomfortable, I'm not going to use this and use the regular whiteboard. Everybody, others, you know what, students? I teach in certain physical institutes. There are we use we use kind of like smart boards. I also use in those institutes, but a regular smart board is also incapable compared to this share screen graphic tablet method. This is really unbeatable than the smart board. Smart board is still behind this because some functions are not available in the smart boards. But I don't want to put you into this one directly because most of you are like still from O level, have no idea about A level. But when it gain more knowledge and more, because in this case we can save a lot of time. So the class efficiency will be increased by somewhere like 60% more, because I am not taking more time to draw the diagrams. I take more time to explain here. I take more time to explain. In the board, I have to draw things. If I drew this in the board, I would take additional 30 minutes to drawing and stuff. මේක හොඳයිද? අනේ මේක හොඳයි සර් කිව්වා. කියමු ටෝන් එකටත් මට hina ගියා. අනේ. Zero error ගැන මම board එකට ගිහිල්ලා කියලා දෙන්න ඕනේ in the real board. I will have to explain in the real board. Now, shall we take one or two readings of this? Two real readings. This method is much better, ne? Okay. Now try. Wait. For this one, even I have to come back to this one and explain, because otherwise I will have to write all the questions. Then the time will be gone. You know what? In my paper classes, I do discuss entire paper in a one day thanks to this one. Let's do first one and the second one. I will give you a time of 3 minutes. I'll give you a time of 3 minutes. Your timer starts now. I'm getting answers now. Wow, very fast. It will only take few minutes for you to catch. Once you catch the method, you can just excel mastered in that. Okay, Lamai, quickly. Right. I will start to discuss. This is more like a real demonstration, real reading. First centimeter, second centimeter. This is the zeroth line of the vernier. Third and 3.5, 3.6 gone. This is the main scale reading, MSR. So what is my main scale reading? That is 3.6 centimeter. That is 3.6 centimeter. What is my vernier scale reading? See, 1, 2, 3, 4. Fourth line is in line 4 times 0.1, sorry, 0.1 centimeter. Now my actual reading is going to be 3.6 centimeter plus 0.01 centimeter. So the reading is 3.64 centimeter. I hope everybody got this answer. As I checked your answers, most of you have sent me the same answer. Okay. Now let's go for the part B. Part B here. Second line and 1, 2, 3. And the third line, it is not the fourth line. See, I have no facilities like this in the regular board. See, how can I enlarge and show you? First line, second line, third line, not the fourth line, just behind the fourth line. That means very closer to the fourth line. Pretty much closer to the fourth line. So let's just diminish this one to the regular size. So the main scale reading, 2.1, 2.2, 2.3, 2.3 centimeter. And the vernier scale reading is, you want me to zoom the first one also? I will zoom. Okay. See, this is more like, for me, it is more like this ninth line. Anybody, somebody may see like 8, no problem. You can take it like 8. 9 times 0.101 centimeter. So the answer of the reading is, main scale reading is 2.3 centimeter plus 0.09 centimeter. Altogether, reading is going to be 2.39 centimeter. Understood? Hello, students. If you couldn't get the answer, copy within like 10 seconds. Do it very fast. Now, one student requested me to enlarge the first one. Okay, see. Main scale reading has gone past in this one, that is the 3.6. Now, in contact, see. Only the fourth line is in contact here. Somebody can make it like 2.5 even. If you have get like a fourth line, it is also correct. If you have get like the fifth line, that's also correct. So for normally in the marking scheme even, they just allow very close by answers. Very close by answers allowed. Okay. So that's all for this one. We have to go back to the regular whiteboard and explain, and while discussing these ones, we can come back to this. Okay, Lamai? Okay, okay, students, I'm go back to the regular whiteboard again. Let's meet in the regular whiteboard again.
Hello, students. Can you see me and hear me? Can you see me and hear me? Yeah. Okay. Now I am going to explain you something about Vernier Caliper. Now it is about Vernier Caliper. Now, right. So far we've learned in Vernier scale. Now we are about to do Vernier Caliper. Write the subtopic, big topic, Vernier Caliper. Vernier Caliper. All right. So I am not going to give you a note like Vernier Caliper is the instrument which used to measure measurements smaller than 1 centimeter, 10 centimeter. On already done. You know that one already. So I am not going to give you a certain silly note like that. But write this. A regular Vernier caliper consisting following parts. Following parts. Okay. Following parts. Right. I had a real Vernier, but unfortunately I can't find it. Where did I keep it? With the box, it's lost somewhere. So in a regular Vernier, you have to draw one. And so in the today's on the spot live worksheet, there is a Vernier. Look at that one and draw that in your book. But in my physical class today, there was a one student who drew it very, very interesting way. I asked them to draw. they took longer time, I told them like, okay, keep space and go back to home and draw it and keep it space. But that dude had finished it. I got really surprised how he did it like this way. See how smart he was. He held it like this and kept it and used his pencil and drew it outside the outlines, and he did it like a very, very, very super fast. You can use the same technique to draw it within like few seconds because you all have the instrument with you. Huh? So you all have the instrument with you. හැමෝම ගාව තියෙනවනේ. So keep it and hold it by here and keep your pencil and draw it very quickly. I even didn't think of that smart way, but he did. That's how the people with high IQ use. Okay, do it. Quickly, don't take more than 1 more minute. I will draw it from here. Don't look at my drawing. Okay, in your Vernier caliper, there is a one side, this one, this part. You can move with that one. This shaft also move, but this is act as for jaw. This is the movable jaw. In this part also a jaw, but that jaw doesn't move. It is fixed to the head. In the same way, see, this is movable, so we call it movable jaw. What do we call? We call it movable jaw or sliding jaw. Movable, you can write it like movable or sliding jaw. Movable jaw or sliding jaw. Don't look at my writing. I already told you, so I just wrote for my pleasure, not to you to copy it. You write in your own words, movable, in a bracket, sliding jaw. This one does not move. See, it does not move. It is fixed. So we call it fixed jaw. Fixed jaw. Fixed jaw. And these two jaws together. These two jaws together, we used to call it as what? If you read my notes, you could easily say, what is the thing? If you read my note in the you could have easily say, what is that? We take the external diameter of something. So we call it external jaws. External jaws. External jaws. Right. And we use this part to take readings of something kind of like internal. Okay. If I want to take the inner diameter of this sellotape, what should I do? I can hold it like this. See, these two edges can hold it. I told you to get prepared something like a PVC tube and stuff while doing this class. So you can hold it. There is a thing called lock screw. You can lock it. In this plastic one, you don't have a lock screw. So you can hold, you have to hold it firmly and take the reading from the main scale. It is somewhere like 73, 73 in the main scale in millimeters. In the vernier scale, it is about 8th line. 8 means twice of this one. 16th line by 0.05. I will tell you how to read this extended vernier caliper as the last part of this lesson. Until then, you only take the main scale reading only by this. Okay? You are going to take only the main scale reading by this. So this part is called inner jaw. Inner jaws. Inner jaws. Right. I told you there is a part in this one, it is not functioning. The screw, you can tight it and lock the sliding. Okay. Likes of this, see. I can hold it. Hold this one by putting this downward. And when I release, it goes. Like the same way. Like the same way. If you tighten this one, you can lock the jaw, then you can take the reading peacefully. Otherwise, you will have to take the reading like a devil. So this one is known as lock screw. Lock the screw. Okay. Here, this part, we use this one to kind of like slide this back and forth. Slide this one back and forth. See, slide this one back and forth. So that is called thumb screw. Thumb screw. Because you touch it by your thumb. Thumb screw. And these lines are known as main scale. Main scale. And this line is called what? Vernier scale. Vernier scale. Right. There is a certain shaft. It is moving back and forth. This is called depth gauge. You can find the depth of certain thing. Okay. We call it depth gauge. Gauge. Depth gauge. Okay, students. This is all about vernier caliper. So don't be silly enough to write notes about what is the external jaws used. Let's straight away go for questions and do it. What is the use of external jaw? To take the outer diameter of an instrument, an object. Okay. See, this is one of the things we have to use in our optics experiments. It is called glass block. See, I can measure the length. It is almost like 103, 104 millimeters. And here, see, it is like, yeah, 18.5, yeah, 18.5 millimeters. The thickness and the width of 63 millimeters. So you can take something like this and find out the volume of this. If I am asking to find out the density of this type of glass cube, that's how the questions are asked. How can you take the measure the density of this one? Firstly, you have to find out the volume. How? Using a vernier, you have to measure all three sides, then tabulate in a data sheet. Then finally, you have to keep this on a, we are going to talk in next week or very next week. It is called electronic balance and or chemical balance or triple beam balance. You have to measure the thing called what? Mass. Okay. When you are measuring the mass, you can finally add this into the equation of density equals mass over volume. So this is how the questions are coming in exam. Okay. I'll place this back in the cupboard. And a regular cricket ball. One of the cricket ball I used. So the diameter is nearly like 72 millimeters. When I take the diameter from the other side, it is smaller than that. It is 70. See, this side 73, this is 70. All because of the seam. Seam is thicker. So this side, when the seam hit the curve, it will just help it to swing. Right? So you have to measure multiple objects whenever you see something measurable. Who use this one and measure and get an experience. Okay, students. So as I told you, you can measure the depth. I'm going to get an old marker pen of mine, and I'm going to remove the inner part of that. It's not removing. Okay, now I want to measure the depth of this one because I can take the diameter, outer diameter easily. I can take the inner diameter easily. But the depth, is this correct? If I take the depth like this, is this correct? Huh? It is wrong. Why? The reason is I have to measure it by inserting this and lowering. Firstly, you have to insert this shaft, then finally lower this one. Now it is perfectly in touch. See, in touch. So now you have to hold it perfectly, firmly. It is about 108 millimeters. Okay, 108 millimeters. These are the usage of these parts. External jaws for outer diameter, internal jaws to measure internal diameter, depth gauge to measure the depth of a hole, right? Depth of a hole. So lock screw to keep it locked when you take the reading, and the thumb screw to move the sliding jaw. That's all. Okay. Okay, students. Do you need to take a note on this one, each part? If you are requesting, I can give you a note. If you can understand, no need to. I don't know, your request. If you're requesting a note, I can give you a note, no problem. If you think like it's quite obvious and understandable, no need to. What do you think? Students, what do you think? What do you suggest? ඔයාලට notes ඉල්ලනවා නම් මම දැන් ටාර් ගාලා දෙන්නම්. ඒකයි මම කියන්නේ. Students, hello. ඕනේ දෙපාරද කියන්නකෝ. ඕන්නම් දෙන්නම් time විනාඩි 5-10ක් maximum 10. Small note is better. Okay. If you are requesting. Now write each part of the vernier caliper, each part of the vernier caliper has a certain, each part of a vernier caliper has a certain function assigned to it. Okay, certain function assigned to it. Now write external jaws. First one, put like external jaw, write an arrow, external jaws, and put like an arrow like this, and write to measure outer diameter or thickness of an object. What is the function? To measure outer diameter or thickness of an object. Right. You can draw it like this. No need to draw the caliper. Just draw the jaws only, parts of jaws. Object. Outer jaws. Quickly, copy this. Copy this. Right. Have a good look at. I used this one actually to find out density in the last year. I could find it, and I used in another purpose as well. See, for finding density of this one, you have to take the whole volume by taking the height, by taking what? Outer diameter, by taking inner diameter, and the depth is perfectly the same height. No need to separately take the depth of this one. So it was a very nice calculation we did in the class. Let's try to do something. I will take all the readings of this one because in this class, I don't think we have enough time. Now your school started, no? In the last year, schools were not started. We had enough time. So I will give you all the readings of this one. Try to find out the density of this material. Okay, I will send all the readings. You may try. Okay, now write internal jaws. Internal jaws. The function is to take the inner diameter of an object of a hole, inner diameter of a hole. You hold it like this, hole, inner jaws. Inner jaws. Now write it like depth gauge, depth gauge, depth gauge. Copy this and write depth gauge. To measure the depth of a small hole. To measure the depth of a small hole. See, hole, this is the hole, depth gauge. Copy this. Copy this. Students, hurry up. Okay, students. Right. Now write lock screw. Lock screw. What is the function of lock screw? Now write lock screw and an arrow. Stop the motion of sliding jaw when about to take a reading. Now imagine I want to take this reading. What should I do? I have to tie this screw here and lock it. So then it won't move like this. It will stay in a fixed position until we read. Then we unscrew it and make it movable again. Now the last thing is thumb screw. Thumb screw and an arrow helps in moving the sliding jaw. Helps in moving the sliding jaw. Okay. Now students, quickly, let's have an interval about 10 minutes and come back around 10 past 10. Interval. Come back around 10 past 10. Okay, students.